Hello, this is Mrs. Bobby, and today we are on lesson 7. There's not much that you missed in the other ones in between because it's just more of the same stuff that we've been doing. So if you need to recap those other lessons, you can just go back and watch those videos again. It's not going to take too much time out of your busy lives. And today we're just going to look at more of the measurement interpretation, which is another way of saying the pictures and how you would look at this. So this is going to be a way of looking at this is how many 1/4 go into 3/5. So the first thing that we want to do, especially when we're dealing with interpretation being measurement, is we're going to make that tape diagram. But before we actually design the tape diagram, we have to get that common denominator. So we're going to use 20 as our common denominators. And we think about how do we get from 5 to 20? We multiply by 4. So whatever we do to the bottom of that, we do to its top. So 3 times 4 is 12. 4 goes to 20 by 5. Do it to its numerator. 1 times 5 is 5. Now we have the common denominators that we need. So we have to get this tape diagram into 20 parts. So there's 20. Now we have to color in 12. And then after that, we have to group them in groups of 5, just like we did yesterday. And as we can see, if we were to group the next 5, we only have 2 out of 5 left, but we have how many full groups? 2. So here's 2 and 2/5. So algorithm method, left side of the fraction gets brought down, division sign becomes a times sign, and we do the multiplicative inverse, also known as reciprocal, as I've been saying. Kids think of it as flipping. When the denominators diagonally are the same, they become 1s straight across 12/5. And how many 5s in 12? 2. That makes 10. 2 leftovers over 5. Another way kids look at that is 12 divided by 5 goes in 2 times. 2 leftovers, so 2 and 2/5. Now, if you look back up here, something that's kind of cool is if the denominators end up being the same, it's kind of like a math problem just with the numerators. See, 12 over 5, 12 divided by 5, if the bottoms are the same. So it's kind of cool. It's like covering up the bottom and just doing the math. But it doesn't always work. It only works when the denominators become the same. So if you take the time to do it, sometimes it makes life a little bit easier. All right, so we're going to look at another one. But what I'm going to do is I'm going to get rid of what we just did, because if you need it again, obviously, it's not like me being in the classroom at the board saying, okay, and you're like, oh, I didn't get it. Well, you actually did, because now you can just rewind me. And as always, if I'm not speaking fast enough for you, you can always fast forward me. All right, so here we go. I'm going to bring this down a little bit more just in case. Here we go. Common denominator, 12. 3, 6, 9, 12. 4, 8, 12, just so you know. 3 goes to 12 by 4, so we're going to do it to its top. 2 times 4 is 8. 4 goes to 12 by 3. Do it to its top, 9. So this is a little strange because when we look at this, 8/12, but we got to group them in groups of 9. So that's not even going to happen. But let's see what it looks like. Okay, and we have 8/12. we have to divide it into 9. We need 9 in a group. Well, we don't have that. This would be our group, so we have no whole groups, and we have 8 out of 9 left over. So our answer here is 8/9, because we don't even have a full thing, because we would have to box this one and we can't. So we have 8 out of 9 left over. So no holes in that. So if we did a standard algorithm, bring down the left, change the division sign to a times sign, and do the reciprocal of that. Diagonals cross out because they are the same. 8/9. That is our answer, 8/9. If we did 8 divided by 9, it does not go in at all. So we have 0 and 8/9. Kind of strange, but not so bad. There you go. Now you can see the 8. And as always, this is Mrs. Bobby, and I still love math.